All right. So like I said, this is going to be Topic 7 review, the final chapter. Rated R. Not really. All right, guys. So let's go ahead and wrap up the last couple problems here. And like I said, I know this was a long chapter, so that makes the review kind of long as well. All right. So look at all this we've done already. So this is what we got left. So hopefully this won't take too long. Okay. So it says, what are all the possible values of b for which 3x squared plus bx minus 8 is factorable using only integer coefficients and constants? Okay, so what does that all mean? Let's talk about that for a second. All right, so this is definitely something that like ACT and SAT love, is doing stuff like this. So what we're basically saying is we've got here, get some rights. So we're going to get this kind of setup, right? And we know that one way we can do this is going to be 3x and x, because that's the only way this part works, right? But then we got some different factors over here. Now, since this is negative, our factors, one's going to be positive, one's going to be negative. So we've got 1, 8. We've got 2 and 4. I think that's it, right? Okay, so what they're asking for is when you multiply this guy back out, what are some of the possible values? All right, so since we can have one of these guys positive and one of these guys negative, so basically what we're doing is we're just going to throw some answers in here, right? So let's start off, we'll make it negative and positive, all right? And let's start, we'll do 1 and 8, okay? So what's our possible v values? Well, that's the inside-outside guys, right? So here we've got minus 1x, or just minus x. And then here we've got 3x and then plus 8x. Now the plus b, the b can be positive or negative. They don't tell us that because we don't know what b is. They just said integer coefficient, so it could be negative, okay? So the possibilities here, we've got that, and then I got to add this, so plus 24x, right? So we have 24 minus 1, so one of the possible answers for b, so b could be 23. All right, so let's check out some other possibilities with this. Let's go ahead and get rid of these guys for a second. So what we could do is we could switch these guys out, right? We could put the 1, we could put the 8 up front and then put the 1 second, right? So we put the 8 here and the 1 here. Okay, so same thing. Inside guys gives me a minus 8x. Outside guys gives me a plus 3x. So then we have 3 minus 8. So that could be minus 5. So that's another possibility. Okay, so you see we're just plugging in the numbers that we have available and seeing what would happen when we multiply the inside and the outside guys. All right, so that being said, let's try another one. So we've taken care of the 1 and the 8. We switched positions for both those guys. That's everything we can do with them. So now we're going to switch over to the 2 and the 4. All right. So let's put the 2 here and the 4 here. All right. So then here on the inside, we're going to have minus 2x. On the outside, we've got 3x times 4, so that's going to be plus 12x. 12 minus 2, that means another possibility is 10. Okay, so it looks like we'll have one more. Oops, I need to erase that. Hang on. That's better. All right, so the last possibility is switch these guys, right? So then we're going to put the 4 up front and the 2 here. So multiply these, we're going to get minus 4 x, you multiply these, I get plus 6x, so it'll be 2x, 6 minus 4. So one last possibility is the b value could be 2. So that's what they're asking here. So we have all these different combinations, and this is the kind of thing we've been doing anyway. Except, we were trying to get like a specific one. So if they told us that b was 23, then we would use the first two guys we did. If they told us b was -5, then we'd use the next two. If they told us it was 2, we'd use these two, that kind of thing. So that's really what was going on there. Okay. Questions? It's all good, man? Cool. All right, let's check out the next one. Oh, yay, another word problem. Just what everyone wanted to see, I'm sure. All right, so let's decipher this guy, see what's going on. All right. So a parking lot has an area of x squared plus 9x minus 5 square meters. Of course it does. You hear that all the time, right? Yeah, okay. It says, use factoring to find possible dimensions of the parking lot. It says the parking lot is to be enlarged so that each dimension is 5 meters greater than it was originally. What are the new dimensions of the parking lot? What is the new area of the parking lot? They want a lot of stuff here, don't they? Okay, so let's start with the first one here. So use factoring to do the possible dimensions. Really, that's just asking you to try and factor this guy. Okay, so let's do that. All right, so go ahead and we say, all right, so we're going to have, one is going to be 2x, right? One's going to be x. One's going to be plus and one's going to be minus, but we're not sure just yet which one. We're going to wipe out the minus sign, right? Yeah, there's a minus sign there. Okay, so then we've got 5. So the only ones we've got here that we can use is 5 and 1. So again, whatever, since this is a positive 9, whatever we put over here is going to get multiplied by 2. So 9's pretty big. It's a lot bigger than 5. So let's put the 5 here. And since the overall is positive, let's make him positive. So that would make this guy negative. Okay, so then let's just double check ourselves, make sure we're okay. So I've got minus x. Over here I got plus 10x. So 10 minus 1 is 9x. So we are golden. So that's the possible dimensions of the parking lot. So what they're saying is it's going to look something like this, right? You have the parking lot here. This might be 2x minus 1, and this might be x plus 5. Okay? So that's the first part. So it says the parking lot is enlarged, so each dimension is 5 meters greater than it was originally. So then what that's telling us to do is, now we've got our dimensions here, right? We're going to just go ahead and add 5 to each of these guys. That's pretty straightforward, right? So it means up here we'll say, well, plus 5 more going this way, and plus 5 more going this way. So it says, what are the new dimensions? Well, we just add these guys, right? So this one would be 2x, and we have minus 1 plus 5, so it'll be plus 4. Okay? And this guy's going to be x and plus 10. Okay, so there's our new dimensions. So that's this part here. So new dimensions, check, got that. It says new area. So to figure out the new area, all we have to do is multiply our guys together, right? So standard operating procedure, we do 2x times x, it's going to be 2x squared, all right? And then we go 2x times 10, that's going to be plus 20. x. All right, we'll move on to the 4. So this guy is going to be 4 times x. So that'll be plus 4x. And then we finally move on to the last guy here. And that's 4 times 10, so it's just going to be 40. Okay, so this is pretty standard. We've got 4 terms because we had 2 terms multiplied by 2 terms. So 2 times 2 is 4. And pretty standard setup, right? We're going to have an x squared. Bring him down. We're going to have a number. Bring him down. We're going to have 2 guys in the middle that we can add together. So 20 and 4 is 24. So here's our new area down here. New area. Okay. So here was our original area up here. And by adding 5 to each side, it changed it from this to this. Okay. Questions? All right, so let's check out a few more and we'll call it a day. It says identify the value of C that would make each trinomial factorable using the perfect square pattern. Okay, so what we need here, there's a pattern to this. This is something that they're not telling you yet, but it's called completing the square. But here's the pattern to this. It's really easy. We take the number in front of the x, that's 16, we divide him by 2. Okay, just divide by 2, right? So that gives me 8. Then we take that answer and multiply it by itself, or square it. So C is going to equal 64. So what it's saying is if you take x squared plus 16x plus 64, this will factor into x, and the number we use here is the number before we squared it, or the number after you divided by 2, so that's this guy. So x plus 8 squared. And again, the reason this works, we've talked about this pattern, is if you go to multiply it back, you square the x, you get x squared. You square the 8, you get 64. If you multiply x times 8, you get 8x, but remember you got to go this direction with it. You also have to go this direction with it. So when you FOIL, you're going to get that 8x 2 times in a row. And 8 and 8 is 16. So that's how we get that guy back. Okay? All right, so let's talk about the next one. Now this works nicely when we don't have a number right here. So this one we do have a number, but we can kind of take care of that. So here's what we need to do with this one. We need to go ahead and, since 2 is an even number and negative 28 is an even number, we just need to factor out a 2. So if we do that, then we're going to have x squared and then minus 14x. Well, now we can do like we did over here, because this kind of looks the same, right? So we say, okay, we take the negative 14, divide him by 2. That gives us negative 7. Now, when you square the negative 7, you also square the minus sign. So this number will always be positive. Always, always, always. Negative 7 times negative 7 is positive 49. Okay? So this will be plus 49. Okay. So now, this isn't quite the original C value because we factored this guy out. So to get the original C value, we just have to multiply it back. So we do 2 times 49, and that's going to be 98. So if we plug that C value in, then you're going to get, as we said, you'll have 2, and then this will be x minus 7 squared. Okay? And that would be your answer. Questions? All right, a couple more and we're out of here. And you guys will head on to your weekend. If I'm not mistaken, you got Monday off, don't you? I think. Because they're making us do some kind of district-wide training, which is a whole lot of fun. Not. So I think you guys got a President's Day or something like that. I think they're calling it. I think. Anyway, I know they got me in some kind of training all morning, so I won't be here anyhow. Sorry. All right, so let's check these guys out. I think you do. Check your calendar. All right, so this says, is the expression 3x squared minus 49 factorable using only integer coefficients and constraints? Why or why not? Okay, so let's check this guy out. So can we factor this guy? All right, so first of all, we can't divide by 3 because 3 doesn't go into 49. Remember how we test that? If you take 4 plus 9, add the individual units in 49, we get 13. I can't divide 13 by 3, so I can't divide 49 by 3. That's just what they call a divisibility test. Okay? So we can't factor that guy out. So the other possibility is I'm going to have a 3x here and an x here. Okay? So one's going to be plus and one's going to be minus, right? So the only factors for 49 is 1 and 49, which I don't think that's going to give us a 0 in the middle. And the other one is 7 and 7. Okay, so those guys are the same. They might, but here's the problem. If I do 1 plus and 1 minus, because we need negative 49, right? This is going to give me minus 7x. This is going to give me 21x. That's definitely not 0. All right, so what if we switched our signs? So let's switch our signs. So what if we made this guy plus and this guy minus? So we do the same thing. That will give us plus 7x, right? And minus 21x. Again, not going to give us 0. So these guys won't cancel out, right? So can we do this? That's a big negatory, right? We just explained why, because we can't come up with a version that has integers, no weird fractions or anything, right? That will give us a 0 for the x term. Okay. All right. All right, guys, one more and we'll call it. How about that? All right. So this says the area of a playground is 36x squared minus 16y squared square feet. Well, sure. Of course it is. It says without removing common factors, factor to find possible dimensions of the playgrounds. All right. So here's what we can do with this guy. This is the difference of two squares. And we've talked about stuff like this. So we're kind of used to something that maybe looks like this. So if they said, well, it was x squared minus 9, right? These are pretty easy because basically you set up shop. And we have an x here and an x here, right? So that's basically taking the square root of x squared. Then the square root of 9 is 3. And with the minus, that means one's going to be plus and one's going to be minus. And the reason we don't get a middle term is if you check inside outside, guys, right? We do plus 3x here and minus 3x here, which equals nada, right? So we do the same thing for this guy. Just take the square root of everything that's there. One's going to be plus and one's going to be minus. Okay? So put 1 plus 1 minus. So we do the square root of 36. That's 6 times 6, right? Square root of x squared is just x. Then we look at the next one. Square root of 16 is 4. Right? And since it's negative, you got a plus 4 and a minus 4. Square root of y squared is just y. Yeah, there we go. Cool. So it said without removing common factors, because we could have pulled out here what looks like a 4, right? Okay, so then it says, we did that bit, possible dimensions. All right, got that, check. For the playground, it says, how are the two side lengths related? Well, one, they're adding the 4y, and one, they're subtracting the 4y. But the 6x is the same, right? So it's just saying one is this much bigger and the other one's that much smaller. So it says, what value do you need to subtract from the longer side and add to the shorter side for the playground to be square? Okay. Well, basically, if we subtracted 4y from here, right, and added 4y to there, then these guys would cancel out and the playground would be 6x times 6x, which would be an equal length. So that would make this guy a square. Okay. Questions? So, ladies and gentlemen, we have made it to the end of topic 7. Yes. So next week we'll start with topic 8. And that's all I got. Just want to thank you guys for stopping by. And go ahead and shut down the recording. I've got attendance already, which I guess is good for Hunter since he skipped out here, but he knew we were done. So, all right, stop recording.